Hey guys, welcome back to Data Products. In this video, we're going to be doing some exploratory data analysis. So what we're going to be doing is we're going to be taking a data set and we're going to be exploring it is the easiest way to put it. So what's the first thing you do when you have raw data? We are going to just jump right in and look at distributions, and we're going to look at residuals and all sorts of things. So this is a long script. So this is probably going to be a multi-part video just because I don't like to make you sit here for an hour. So without further ado, let's just dive right into it. Alright, first things first, pull up your RStudio. Clear that out. For those of you that don't know, Control L clears out your everything. Alright, let's do a new file, and let's do an R Markdown file. We'll call this Exploratory Data Analysis. We'll say OK. I wish I could clear that out easily without getting rid of the YAML, which is the top part there. Alright, so first let's load a required library. We are going to use the library rcurl and library dplyr packages. What rcurl does is it allows you to get data from remote sites. So in this case, I'm going to just copy and paste this. I'll try to remember to put this down in the description so you can just copy and paste it. I hope I don't need site. But this is the website that we are going to get the data from. This is New York Times COVID-19 data for colleges. So we'll be looking at some real data from the COVID-19 pandemic at universities. Read.csv site. So what we're doing is we're saving this URL into site, and then we're saying read the CSV from this site. Oops. Oh, this has to be in our brackets. Duh. Okay. And we'll say now let's get our data. All right, so I'm going to run the. Oh, there's no E in dplyr. Okay, and now we'll get our data. So you see we have this college data. We have what college it was, the city the college is in, the county the college is in, the state, the date that we got the COVID-19 data, which looks like it's all the same date. Maybe. Yes, so it's all the May 26th, 2021, the number of cases in 2021, and then they had some notes here. Okay. All right. So first, let's load the str. Or I won't say load. Let's use the str function. This shows the structure of the object. So we'll do str for structure of college data. There we go. Okay, so we run this, and you can see it's a data frame. It tells us it has 1948 observations with 9 different variables, and lists our variables: date, state, county, city, IPED's ID. I'm not quite sure what that is. And the college, and then the case is 2021, and then the notes. Okay. What if we want to arrange our data set alphabetically by college? Alright, so we can manipulate this a little bit. Alphabetical is college data, and arrange college data, and then we say by what? By college. Okay, so now alphabetical is the same thing, but if you look by college, we have Abilene Christian, Abram Baldwin Agricultural College. I have no idea Georgia, Adams State, Adelphi, Adrian, etc. So, yeah, so kind of the default of the arrange function is to do it alphabetically if it's or numerically, and descending or ascending numerically and ascending alphabetically. Okay. The Glyphs package is another way to preview data. So if we use the Glyphs, I should say function, but if we use Glyphs, it'll give us a glimpse of our data. So you can see here, it just displays it in a different way. So we have the number of rows, the number of columns, and it tells us the characterization or the type of data is. So the date's a character, state's a character, county's a character, etc. And then it lists out the first however many it can fit in this area. So Alabama, 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 states, etc. Okay. So, I mean, structure, and if you compare structure in this, they're similar, just different layouts of how you want to look at it. We can also subset with select. So college cases, I'm going to say select college data and then college cases. So if we want only, oops, I put this in our block. Say we want only, we don't want the city, the county, and stuff like that. We don't care about that. Well, we can do the select function, college cases, then we just have the college and the cases. Okay. We can also filter or subset with the filter function. So let's say Louisiana cases is filter college data state equals double equal sign. Make sure you use the double equals Louisiana. Oops. Oh, and man, I'm just skipping my R blocks constantly here. Okay. So we have Louisiana cases. So we have 41 colleges in Louisiana that we have data for. You can see the number of cases. Yeah, so let's keep working. And so we're not going to use this whole data set. Smaller amount of states. So we're just going to do we're going to call them South cases. And we're going to say filter college data state equals Louisiana. And then the straight up and down line, which is above your enter key, which means also. We're going to say state equals Texas. Then the same thing up and down line, state equals Arkansas. And then lastly, state equals Mississippi. So those will be our southern cases. Oh, I need my double equal sign. See, that's what happens if you don't use the double equal sign, is you get errors. There we go. So southern cases. So we have 173 colleges in those 4 states. So you can see we have Arkansas, Louisiana, Mississippi, Texas. All right. So we'll come back to this. So now let's look at some time series data. All right, and so we're gonna first we'll load the required libraries for this. All right, so library, lubridate, library dplyr, which we already have going, ggplot2, library grid extra, and library scales. Okay. All right. Now let's load some data. We're gonna say state site, and then I'll try to post this below. Which is another New York Times COVID-19 data set. And we'll say our state data is read.csv state site. Oops. Put that quotation or that parenthesis back up there. All right, so let's load this data. Okay. Let's create group by object using the state column. All right, so what we're going to do is we're going to say state cases is group by state data is the data we're going to use, and we're going to group it by state. And then we're going to say class state cases. Okay, so first actually I'm going to look at the state data, right? Because I didn't even look at it. If the state data here, we have the state, we have the date reported, we have the cases, and we have the deaths, right? So as you can see, and very early in the pandemic, 2/12/2020, there was one case in Wisconsin and 0 deaths, but as we go, further into the pandemic, you see that the deaths go way up because the pandemic, obviously, COVID spread everywhere. Now let's look at all right, I gotta find where I'm at here. And then we do class states. Let's run that real quick. Oh, did I run this? I don't think I ran this yet, have I? There we go. So it says it's a Tibble data frame, group by data frame. So that just kind of shows us what we've created. How many measurements were made by state? This gives us an idea of when states started reporting. All right, days since first reported. And we'll say tally state cases. All right, so tally means to count, right? To take a tally. And so from this, we'll be able to look at the states that, let's organize this. So the first, this is accurate. The West Coast was the first hit. I didn't know Illinois was so high up there. But Washington and San Francisco, I think, were the places where COVID first was detected in the United States. And as you can see, those are two of the first to actually see cases, right? Or start recording this data. And then it started to spread. I think it started in the coasts and then kind of went inward, right? Because most of the travel and the population are on the coasts. And you can see that, like, Guam, the Mariana Islands, American Samoa, Puerto Rico, these isolated areas were much later hit. Alaska, places that there's not as much travel. We were pretty late hit to Louisiana, me being located in Louisiana, for those who are not in my class, but watching on YouTube. All right, so we can use this tally function to get an idea of something from our data that we didn't have before, right? So days first since first reported. Assuming everyone reported when they did have cases, there are, it's possible that cases weren't reported and that it was here before we were aware or things of that nature. But we can only, use the data that's given to us. But that's information we can glean from this data that wasn't specifically stated by using this tally function. Okay, so let's visualize some data. All right, actually, we're gonna make some notes here. First, let's start off with some definitions. Data, obvious stuff we want to visualize. Actually, I'm not going to put that there because since it's a markdown file, it would make it like a header. Layer, made of geometric elements and requisite statistical information. This includes geometric objects, which represents the plot. So when we are doing things like ggplot, it'll ask for a layer. We'll add layers like geom layers, and so that has the geometric elements that we're putting onto the plot. So you can imagine a white piece of paper as our ggplot object with some info in there, and then we're putting layers of images on top of that, right? Okay, and then we have scales used to map values in the data space that is used for creation of values. Color, size, shape, etc. So this, scales are the things we see that we can manipulate. Coordinate system describes how the data coordinates are mapped together in relation to the plane on the graphic. Faceting, how to break up data into subsets to display multiple types of or groups of data. And then theme, this controls the finer points of the display, such as font size and background color. Okay. So what are we at? 18 minutes. Okay, so we're gonna stop on that part one here. So these are the things I want to end on. So these definitions, keep these in mind while we're going through things. So if you ever, when we get to actually building these graphs with ggplot, especially because it uses a lot of these things, if you have a question of, man, what was that again? You have the definitions now. We're like, why am I adding this line of code for facets or for geom layer or whatever? That's just an aspect of these graphs, right? And so we have the definition, and it'll make sense if you keep these definitions in mind while we're going through the code, then you'll be able to put it'll make sense. And like I said, this is all learned by doing. That's the best way to do it. Like memorizing these things, not important. Having a reference, if you have a question in your mind, if you're like, what is a facet? Having the definition to go back to, that's good to have, but just know that they're there for your convenience. So that's it for part one. We're going to continue on in our preliminary data analysis, exploratory data analysis here. And like I always say, if you're watching on YouTube, hit like, hit subscribe. That would be very helpful to me. There's going to be more to this lecture in another video. I hope you enjoyed the video, and I'll catch you in the next one.